So in this talk, I will introduce and analyze the rOpenSci onboarding system, which is a system for package reviews. Now, I've heard that some of you are beginners who got introduced to R this week at the data carpentry workshop, or maybe are beginners who don't even know yet what a package is. So just as an introduction, a package is a plugin that people add to the R language by contributing it, and that's how you can do all sorts of cool things in R. Before getting to the main content of my talk, I wanted to say good morning to you. So Catherine said I speak several languages, but I don't speak many of the South African languages. So I asked my chibi designed by Ozlak, to tell good morning to you in a few South African languages, and I did that using the Magic package for image manipulation. I also wanted to present a few our organizations that are very important to me with stickers and the Magic package. So I work for rOpenSci and Log Data. rOpenSci will be presented at length in this talk, and Log Data is a data science consultancy funded by Steph Locke, whom you might know if you were here last year because she was a keynote speaker, and she actually co-founded satRday. So that's thanks to her we're all here today. And I'm a member of Our Ladies. Our Ladies is an organization aimed at increasing the gender diversity in the R community. There is a local chapter here in Cape Town, and we had a great meetup on first day. And I'm also a team member of Our Weekly. Our Weekly is this cool newsletter where you will read about blog posts, new packages, and conferences that happens in our community. So you should check it out to be informed and also send your content. I have stickers for rOpenSci, Our Ladies, and Our Weekly, so contact to me if you want stickers. And there are two other Our Weekly team members here, John and Larry, and you could also talk to them about Our Weekly. Okay, and I've come a long way to give this talk. I live in France, in Nancy. I wanted to give you an idea of how it looks like. So here I am posing in front of the Stanislas Square, which is a really nice square. Another touristical highlights in my city is this Parc de la Pépinière, and they're quite close to one another, and they're only separated by a small square. And I recently discovered that this small square is actually the Nelson Mandela Square. So there is a small part in South Africa, in my city. So back to the content of this talk. So what's rOpenSci? rOpenSci is a community of researchers and software developers whose aim is to support open and reproducible science via R packages. And these packages are both contributed by staff members, but also by community members. There are many rOpenSci packages. You can find them by browsing this web page. I'm going to show a few to give you an idea of the diversity of rOpenSci packages. So you have packages for visualization, such as HeatMapper by Alicia Schrepp, that does interactive complex heat maps. And there are packages for image manipulation, like the Magic package you saw in my first slides, and also packages for taxonomy. So I've already heard two ecologists today, so if you're an ecologist, you might be interested in that. So many packages contributed by both staff and community. So how do we ensure quality in this whole ecosystem of packages? Because we want users that we use an rOpenSci package to have a good experience. So one way we do that is by our open software review. If you're an academic, you use a system for reviewing papers, and that's quite similar in the sense that an author, before their package can be included in the rOpenSci packages, has to get it reviewed by two independent people who will make comments and suggestions for improvements, and the author will have to change their package a bit before getting it onboarded. So why would we do that? We'll do that to drive adoption of best practices and standards. Interestingly, this effect is not only on our packages, because if an author or reviewer gets exposed to this best practice set that we have, then they will use that in their over our tasks. It builds a community of practice, all these people working together on better software. And for academics, there is a nice perk. You can also write a paper. We have partnerships with two journals, the Journal of Open Source Software and Methods in Ecology and Evolution, so you can get academic credit for your software work, which is quite important. So what do I mean by quality when I say we want to ensure good quality level on our packages? So here are a few criteria. So we agree with this image by Jeff Lick. So documentation and usability are more important than speed and statistical superiority, for instance. Because if you want people to adopt a tool and you want this tool to really help their work, then it should be usable and well documented so that they can know how to use it without spending hours understanding what the package does. So more precisely, what we are looking at is that we want the package to have an open source initiative recognized license. We want complete documentation. So when you use an R package, you have documentation for functions, but we also enforce having at least one vignette. A vignette is a long-form documentation. So that's a place where you can show how the different functions of your package interact together and how your package fits in the R ecosystem, how it interacts and complete over our packages. We also want high test coverage. So here maybe I'm losing some of you. So if you don't know what a unit test is, when you write code and say you have a function that will tell you in which city UCT is. So the answer should always be Cape Town. Now you try to modify your code, you try to replace this for loop with something else, and now your function returns Pretoria. So that's wrong, your package is broken. So how would you know that? Each time you make a change, you don't want to test that everything that was previously implemented still works. So you will implement a test and run it every time you modify your package so that you see that all these things still work. And what I mean by high test coverage, so the coverage means how many lines of your code do have this robustness, how many of them are covered by a test. So quite a few of our packages don't even have unit tests, so in our onboarded packages there are tests, and there are many of them, so that's a good way to ensure quality. And we ensure also readable code, because reviewers are going to read the code. Of course it will have to be readable, otherwise reviewers will complain. And usability, of course, is something we want to ensure. And when you have two external people looking at a package, they will notice what's not usable. They're not the package developer, because the package developer is quite, he or she are quite accustomed to their own package. And they don't have this external perspective that reviewers bring. You will find all our criteria for good packages in this guide that I am in the process of transforming into a book down. Now, how do we review technically? So we review openly. You can find all review on the internet. I will show you that, and not in a non-adversarial way. So if you're an academic and know the peer review system of academic journals, you might find it a bit adversarial. So that's not the case for the onboarding system at rOpenSci. There are no rejections once a package has entered our system or process. Then we make the processes constructive for everyone, so everyone is learning something along the way. And technically, we use GitHub infrastructure. So you can, in R and other programming languages, you can use version control to track your changes. So you can use Git for that, and GitHub is an interface to Git, and you will see that it has nice features that we take advantage of. Now, at this point in my talk, I thought you'd be interested in behind-the-scenes detail. I wanted to show you stuff on GitHub, and I thought, well, maybe I could browse the internet directly, but I knew I would be quite nervous by now. I'm not able to go to the internet and navigate to a web page, so I decided to do screenshots. And because this is a behind-the-scenes detail, and I want you to know that, I'm going to wear this until I'm done with this detail. So in R, you can actually do screenshots using the WebShot package, and it's a great one. You can input an URL, CSS selectors, and really get the screenshot you wanted. Now, its limitation from my use case is that this WebShot, do you still hear me? Okay, so is that this WebShot gets written to disk. So if I do a screenshot, if I make a screenshot with WebShot and want to integrate it in a presentation, then I need to write a path and then write it again in my slides. So I decided to write a wrapper using the Magic package, because Magic image I automatically rendered. So you see this function takes a screenshot and then reads it from disk, removes the disk file, and returns the magic object. So see, I can make a screenshot of what I wanted to show you, the rOpenSci onboarding repository. So that's great. That's the place where onboarding takes place. Now what you can see here is this big rectangle telling you to join GitHub today. You should do that if you're not on GitHub yet. That's a great place to get involved in open source development and to stock package developers, but that's not what I wanted to say. So I decided I needed to be logged in to take this screenshot. So I decided to log Maelle. If you read WebShot documentation, they tell you if you are familiar with JavaScript, then you can send JavaScript code to the web page before taking the screenshot. Now, I'm not familiar with JavaScript, but my friend Bea coached me, and I could write 3 lines of JavaScript code for this. And a key point here was to use the return URL instead of the URL. What I mean by that is that on the previous web page, if I click on login, I would get to this web page. So you see in the URL that it's a login page, but once I'm logged in, I return directly to the web page I wanted to see. So I wrote this wrapper. It transforms the normal URL into this return URL, and then sends my password and username, then click to log me in, waits a bit, and takes a screenshot. This is a fake GitHub account that was useful for this and also for my workshop yesterday, but that's not very safe, obviously, to have your password somewhere on the computer. And also note, well, technically, this is only for my screenshots. If you ever need to interact with GitHub with an R code, you should use its APIs. We will see that later in my talk. So here was an edge case where I wanted to show how the website looks for a human while writing an R script. So now I can get back to the general content of this talk. So this is the rOpenSci onboarding repository. This is where all our reviews take place. So in the repository itself, you see that we have a few Markdown files that are templates and guides. The real star of the show here is the issues tracker that you find here. Each of these issues here is one review. So the concept of an issues tracker on GitHub is that it's a place where people that use the software can report a bug, but we use that for reviews. So each of them is an onboarding process. And as I said, we make the most of GitHub infrastructure, so we use labeling. So you see these labels here. The yellow label indicates that it's a package, not someone asking us a question, for instance. And to show the progress of a submission, we use these numbered labels. So this package was, when I took the screenshot, at the stage of seeking reviewers. And this one has the reviewers assigned, so we were just waiting for the review. We also use the assignment feature. So in the software development context, this will mean this person has to fix this issue. Here it means that this is the editor. So I was the handling editor for that package, and Noam is the handling editor for that package. So that's how we use this system. Now, say you are a package author and you want to submit a package. How does it look like? So if you are the author of the Borebot package, when it didn't live in the rOpenSci organization yet, so you have your package, what would you do? You would head to the issues tracker here and click on new issue, and you would open a new issue. You would have all this text already filled. This is our submission template, and it asks you a question about your package. What does it do? And why would it be a good part of the rOpenSci ecosystem? So that's an important thing. I said there is no rejection in our system. This is true for the packages that are in scope. And some packages wouldn't be relevant for our mission, and we don't onboard them. So what are our policies? So we have categories of use, such as data retrieval, data extraction. Then the package needs to be quite specific to science, so not too broad. And if there are similar packages around, it should be a bit better, like it should have more features, for instance, or have a better interface. And if an author has a doubt about their package, they should open a pre-submission inquiry. So what does it mean? They open an issue, and they tell us they're not sure their package would fit. So that happens to this package. This package doctor is a cool package automating EDA workflow. So we're not saying that's a bad package, but it doesn't fit into our mission, so it was deemed out of scope. Now, this package, Borbird, on the other hand, helps scientists maintain a local collection of data, so it's in scope, so this issue was closed, and the author could submit their package a bit later. So this is one review process, and it's only the top of it. So each review process is a long thread of text, and there are some important steps in the process. First step after the submission is an editor doing editor checks. Editor checks are quite basic checks of the package, well, that it's in scope and that it builds, for instance. And this is also the place where we assign reviewers. We often don't assign them right away, but we update this comment with their name. So a note on reviewers. How do we choose reviewers? We have 2 of them, and we want them to be diverse, to really reflect the diversity of our community, and this in particular in terms of skills. So when you have someone 2-person reviewing a package, you can have someone that will be more an expert of an aspect of the code, for instance, and someone who would use the package in their day-to-day life, so would be more interested in the interface. And these 2 reviews will then complete each other. So that's how we try to recruit our reviewers. So this is the first step, editor checks. Then will come the second important step, review. So this is one review, this is the second review. So you see these reviews are very long, and not always that long. But reviews are very insightful for package authors, because that's the moment where an external person looks at the package and says, yes, it makes sense, yes, it works, and it's useful, and it could be even more useful if you did that or that. So that's a great moment in the review process. So although there are these important steps, this is an ongoing discussion. So compared to an academic journal where you send your paper, you receive your reviews, you write an answer, the editor takes a decision. Here you can, as an author, you can say, hey, I didn't understand what you mean by this modification. Can you explain that? Or would it be okay if I tackle this doing that? So it's really an ongoing discussion until acceptance of the package and transfer to our GitHub organization. And this process often ends with a blog post, so you can read more about packages and the process at this tag. So now at this point in my talk, you know what the review process does. But because we are at a data science conference, I wanted to give you a data-driven overview of the process, how to do that. So for those of you who were here last year, you might remember Jenny Bryan's talk, and that's where the answer is. So I decided to rectangle onboarding. So what do I mean by that? So to make a visualization or an analysis, you need data in a data frame in a rectangle. So rectangling onboarding was an important part. So again, this is going to be a behind-the-scene detail of my talk. So I will explain how I got the data. So data about onboarding lives in the issue tracker that I've shown you, so all these threads, but it also lives in the onboarded repositories themselves. And I will explain how I got data from both these sources. So I want data out of this. I want for each issue its title, I want the labels, I want to know when the issue was open and closed, because it's being closed means the package was accepted. And I want to know what's the assignee, I want all the text. So how to get this data from GitHub? So GitHub has APIs, so application programmable interface, and they will help me with GitHub issue threads. GitHub has 2 APIs, v3 and v4, so you might assume that v4 is better, and I think a great difference between the 2, if you read about them a bit, is that v4 gives you only the data you need, so not junk data. So what was my experience with this GraphQL v4 API? Importantly, I had no experience with GraphQL before getting the data for this talk. So how did I do that? I used all the crutches that are available. I used the Online API Explorer to build my queries. I used an rOpenSci package, the HQL, to interact with the API. Then I used another online tool, JQ Play. JQ is a powerful query language for JSON data. And you can use JQ in R with an rOpenSci package called JQR. So I'm going to show you this tool, what they look like, and then I will walk you through a minimal example of interacting with GitHub before API. So this is the Explorer I've mentioned. So if you want to get data out of GitHub, you need to write a query. And here you can log in, write your query here, and then execute the query. The reason why this is so great is that you can run the query just clicking on the button. And this part here has auto-completion, so it will only let you write things that exist. And you have the docs here on your right, so you really help. So if you do that and Google a few examples, it's easier to write a query. Then in R, you can use a JSQL package to get the data using this query. And what you get is JSON. JSON is not a rectangle, it's nested data. So what I did is copying the JSON into my clipboard and I went to another online thing, JQ Play. So JQ Play lets you paste JSON here. You write a JQ command here that you can find in the documentation or go around, and you see here what it does. So that's how you can really play until you find the right command. Then I will show you a minimal example for my own package JH recipe. So that's a place where you can see my using the API for getting data I needed and learning how to use that. So maybe it's useful. It'll be useful for you if you want to use it for API as well. The function I'm going to demonstrate is called getContents, and what it does is getting the contents of a repository, but only the highest level. So here it will tell me I have these 3 folders and these files. So how does it work? First, in R, you need to create a client that will be your messenger to and from the API. So you so you first need to authenticate using a token. If you've ever used Twitter API, for instance, this is a much easier way to authenticate. So GitHub has great API about how to get a token. So it's not too complicated. And then you create the client, you load the schema, which is a GraphQL specific concept, and you need to write a query. So this is my query. So you see there are a lot of curly braces. That's when you are very grateful for the Online Explorer automatic completion, because it wouldn't let you not close a curly brace and get a wrong query. So just a few comments in the GitHub GraphQL API. Files lives inside commits, and here you can see I need to specify the owner of the repository and its name, and then I will get the entry. Last part is executing the query here, so doing this and doing that here, and then I have this pipeline. So I get data from the API here, and I have this pipeline using here JQR. So if you read this line, that's my JQ filter command that I built using the Online Explorer. If you know XML, this is a bit like XPath for JSON, and it's very powerful and compact. And then because it was here a string of characters, I did a few more modifications. So that's what I would get from the API. So I say I want to know what's in the onboarding repository. This is what lives inside the onboarding repository. So I used such a workflow to get all data from the issue thread. So I call that magic, but now you know that just by using all the possible helpers that are around. And I wrangled it a bit, because when you look at issues from the onboarding system, for instance, someone opening an issue is the author, so that's a piece of information I was interested in. And I got this. So this is a rectangle of all the data from the issues tracker. There are more than 2,000 lines here, and each of these lines is a comment in an issue from our onboarding system. It has a title, it has a date when the issue was created, when the issue was closed, body from the comment, who wrote that, etc. So great data. A small glimpse into the data. There are here data about 70 packages. And if you look at the number of comments by onboarding process, you see that there are a lot of them, which supports what I told you about it being an ongoing discussion. Okay, But there is data living in the onboarded repositories as well. So we are a system for reviewing packages. So our end product are packages, so I want data about them. And because they are under version control, I will get data about them and also about the changes. So it's as if we got to sit behind someone and seeing this person doing changes in their Word document, say. We see every changes. We see the package from draft to working package. So I wanted all this data. So how did I do that? I cloned all repositories of onboarded packages to my laptop, and I did that using an rOpenSci package, Git to R, that lets you interact with Git using the libgit2 library. So I had a local copy of all these repositories, and then I used the time machine. So because I had this rectangle of the onboarding issues, I knew when a package had been submitted, and I could find the latest change before submission. So for each repository, I made a copy, and I reset this copy at the pre-submission stage, so really how it looked like before being onboarded. Then I got commit logs using gitsum. So you could get commit logs using git2r, but gitsum by Lorenz Waltert has very nice high-level functions for getting commit logs, which is the reason why I used that package. I got the number of lines of code in the repository using clock. Clock is an R package by Bob Rudis. Clock is a Perl script, so this package wraps. This Perl script clock means count lines of code. And I got the number of exported functions and classes using this DevTools function that passes a namespace. If you don't know what a namespace is, so when you use a package like ggplot2, this is the file where you would see all the functions from that package that you can use. geom histogram, geom point, geom line, they are all listed in that file. Okay, so now I can remove my safety helmet. And I say let the fun begin, but I actually enjoy data collection as well, so this was fun as well for me. The full code of my data collection here will be reported in blog post on our rOpenSci blog. So now in the following, I will use this visualization packages, so ggplot2, to get nice themes, rmaster, a package of Bob Rudis, and Viridis to get this colorblind, friendly, and pretty color scales. Okay, so the first question I wanted to answer in my data-driven overview of our rOpenSci onboarding system was how much work is onboarding. So I always had the impression it was a lot of work with people improving packages and reviewing them. But here are a few more data-driven answers. So first, I looked at the work done in repositories themselves. So Charlatan is a package that has been onboarded. Here on the x-axis, you see time. And this gray rectangle indicates the onboarding process. Now, each of this vertical line is a commit, so it's a change. At this point, the author, Scott, made a change in his package. And above the y-axis, you see the number of lines that were added, and below the number of lines that were deleted. So the higher this line, the bigger that change was, and the more frequent these lines are, the more frequent work was. So what you see here is, for instance, an increase in activity in the repository at the end of the onboarding process. When the reviews were in, the author made a lot of change to his package. Another package here, devfrom. So in that case here, you also see a lot of activity during onboarding. So a lot of work was done in the package at that stage. And the last example, Gutenberg. Here, what's really interesting is that you see a lot of work right before onboarding and during onboarding as well, because this package was submitted as a very young package. Now, I looked at all these figures, and there was no general pattern. A reason for that is that this package are onboarded at different stage of maturity, although we do onboard only packages that are already quite mature. Is also due to the fact that package authors have different levels of experience with R, so you have different patterns. But what's important is that I really got to see that during onboarding, there is always work and changes happening, and I could prove that with such graphics, and I guess one could explore this data even more. I said packages are onboarded at different maturity stages. A way to look at that is their age. I say apparent age here because the way I measured age of a submitted package was the difference between the point in time at which it was submitted and the first commit. So the first time there was a commit on GitHub, and of course an author could have worked on their package even before that. So that's how it looks like. So I found interesting to see that many packages are onboarded, submitted before being 1 year old. And you see all these packages here that seem to have been submitted right away. And I know from my perspective as a package author, there are a few packages of mine where I thought, I'm going to do my best now implementing them. And now that I think they're ready, I think they could be useful for the rOpenSci community, so I'm going to submit them. And I'm going to do that now because they're going to be improved by this process. And so another way to look at the work quantity that onboarding is to look at the size of packages. Of course, a big package could be one with a lot of code duplication, but it's a good proxy to look at the size of a package. It will indicate work by the author. The author had to implement their package, and the reviewer will have to read the whole thing, so it's also a good proxy. So I look at the number of lines of R code in packages. So this is for rOpenSci and CRAN packages. Bob Rudis has a local CRAN mirror at home, and it was nice enough to run my code on all the CRAN packages, which is why we can get this density plot. This is a logarithmic scale, so this is a distribution that has a long right tail. So you might think, looking at that rOpenSci packages are a bit bigger, but here this is a very crude visualization because I looked only at R code, and packages sometimes have other languages inside them. rOpenSci onboarded packages most often have R code and sometimes CPP code, but it's not as diverse as CRAN itself. In any case, what I found interesting here was to notice that some packages are actually quite big compared to the general mass of packages. I then look at the number of exported functions and classes, and it kind of looks the same. So there is a long right tail here of packages that are quite big. And it was interesting because now I wonder if in the future when recruiting a reviewer, we should tell them that they're going to have to deal with a very big package. But then we also get reviewing time. So that's something we get because at the end of a review template, we ask reviewers how long did you spend reviewing that package. So it's quite useful information for us, and you see that it's most often a couple of hours with a few reviews taking much more time. So I tried to correlate that to the size of the package. It didn't correlate. And I think a reason for that is that as a reviewer, you will spend more or less time depending on the time you have anyway. So you have a time allowance. You won't be able to review for days. And it will also depend on your experience as a reviewer. Maybe you're learning things about our package infrastructure at the same time as you do your review, or maybe a reviewer will spend a lot of time on a package because that's exactly the package they would use in their day-to-day work, so which would be a reason for spending more time. But in any case, that's a lot of work with people spending at least a couple of hours reviewing a package from someone else on a volunteer basis. So last notes about work quantification. So as you see, it was hard to define metrics for quantifying work. And I really want to underline that what we were looking at was work by volunteers. So these people, maybe some of them can do rOpenSci reviews and rOpenSci submissions during their work, but they're not paid by rOpenSci. So they are volunteers, and we're very grateful for all the hard work that's been done in this onboarding system. And we want to decrease the time everyone has to spend doing this by automating the system even more. I will come back to this later. And what about editors? So what do we do? So I like this quote by a package author. So Tim Try says that we are guiding angels from start to finish during the entire onboarding and review process. So what we do is making these checks, recruiting reviewers, and making sure the process goes forward, so sometimes nudging people a bit along the way. Another thing I wanted to look at with data is But when I try to promote the onboarding system, I say that it's a high quality and friendly process, and you should get involved because of that. And most often, I also, my co-editors will use anecdotes, so like tweets. And by the way, this is a very cool function in our tweet where you can do a screenshot of a tweet, only giving its tweet ID. So here is a package author Andy South, and he thanks rOpenSci for the great package review process, and he thanks a reviewer, second reviewer, and the editor. So, hey, it looks quite happy. And what? What do we do? Okay. Oh, it doesn't work. Oh. Mm-hmm. Oh, so now it okay, I don't know what I did. Okay, now it, so, and here is a reviewer, Laura Graham, and she had just done her first review, and she says the documentation makes the whole process straightforward and enjoyable, would recommend. So she's happy, and here is the author saying thank you again. Why again? Because of course the author already said thank you in the reviewing thread itself. So it all looks very cool and friendly, but with anecdotes. So how could I get a more general overview of the systems? Now, I recently read an essay in the very good book Open Advice. So if you're into open source software development, which I guess many of you are, you should read Open Advice. And there is an essay by Anne Gentle where she defines the concept of the social weather of an online community. When you enter a restaurant and you look around, you see what kind of food you will get and what the atmosphere is. So how can you get this same overview when entering an online community? And if you were here last year, you also heard a keynote talk by Julia Silgi about tidy text analysis. So this is what I decided to do with all this text I had from the onboarding process. So here I won't give many details. So I clean text by tokenizing it into lines. And I use a tidy text and sentimentar package. And I was helped a lot by this very good book by Julia Silgi and David Robinson, which is available online, and which you can also buy as a paperback book. So the first thing I looked at were the most common words in the onboarding threads. And very surprisingly, for a system for package review, the most common word is package. And other words that you see here are related to words you know from package development. So it looks we're dealing with a thing that looks at software. Then I look at background. So what is a background? Background is a pair of words that go together. And this has the most common one. So the most common one is blog post, because we often ask authors and reviewers whether they would like to write a blog post about the process. And then you see things related to packages, description file, data frame, command check, error message, but also good ideas. A good idea is one of the most common background in our process. A last visualization to show what the onboarding process is about is that one. So it's a pairwise correlation network. So these words are not bigrams or trigrams. They often come on the same line. And we see some interesting clusters. So for instance, you will see here a lot of mention of pull request and of command check again. And here is a small cluster linked to what we ask when packages are also submitted to the Journal of Open Source Software. They need to have their performance claims confirmed. And you also see the work of editor here. So somewhere here, yes, I have the friendly reminder. So we often friendly remind people to submit their review. And we used to have a bot, and this bot would tell people, hey, it's been 3 days since you had to submit your review, please get it in, and it was a nice bot, so it had a smiley cat emoji. So looking at this, I now know that this system is about reviewing software, but is it really friendly? So for that, I look at the sentiment of lines. And this is a sentiment of all lines in this phrase, and you see that it sort of looks similar for authors, editors, and reviewers, and it's most often positive. So yeah, it looks friendly, but what are these negative lines? So note that we have a code of conduct. So there is nothing really mean and rude happening, and if it happened, we would just act upon that because we don't want that happening. But what are negative lines? So I looked at the most common words in these negative lines, and it looks similar to the most common words in the issue in all the lines. So packages, function, issues, errors. So I thought, oh, this is probably people solving bugs. I also looked at the most negative lines, and you see things such as not sure what you mean, but I use different object names, error. So this is the line of code. Actually, when I cleaned the text, I removed code, but I could only remove code that had been formatted as code in code chunks. So this was code that had been pasted as normal text, so I couldn't remove it. In any case, when looking at that, what I see are people solving issues and bugs and problems in software, which is great to see as an editor. If you think of scientific software in general, or our packages, often they're not reviewed, often they're not tested, so there are problems, but it's just that no one saw them. So here, we're making software better, and the problems, many of them are found and solved at that stage. And I said I don't want to rely on anecdotes, but I still couldn't prevent myself from looking at the most positive lines. So here they are. And you can find things such as a reviewer saying that this is a well-organized and readable code, and this package is a great lightweight addition, blah, blah, blah. So we encourage reviewers to start their reviews or end it with a compliment with that by telling what they liked in the package. So it's really non-adversarial. They're not only saying what they don't like and what should be changed in the package. And you also see an author saying, I'm delighted that you find my work interesting. So authors are pretty happy too. Okay, so I'm done with the data-driven analysis. I wanted to mention again our automation effort in this system. So automating is important. This way you can let humans focus on what humans are good at, for instance, as reviewers, being these external humans using a package. So what have we already automated? So we use all these tools to review packages, to our command check, that you might know to find some issues, and we use these tools to see if tests pass and if the coverage is high. Then there is DevTools spell check. So this might sound not important, but removing typos from your documentation is important so that a future user of your package has a good experience reading and using the documentation. And lints the package, so it's static code analysis. Things it will tell you will be, for instance, there are no white space in this line, or this line is very long. And it's like with typos. You don't want these things in the code to distract future contributors and reviewers of the code. So you don't want to divert them from looking at what the code does. So if the code is has a good style, it's easier to read it and to debug it. And we also use good practice. It's a great tool to get things such as anti-patterns in the code, or it will also find too complex functions. And I have actually written a blog post where I present and describe these different tools in case you're interested. And we want to bring even more automation, and that's actually part of my work to bring more automation into the system. If you know DevTools release, we would like to have something similar. So right now, you have seen that to submit a package, an author has to navigate to the issue thread and then write text there. So we would like this to be possible from R itself, so submitting your package without leaving your R console. Anna Cristalli, when she made a second review for us, she realized that there are some things that could be automated to help our reviewers set up the project and use the review template. So she made a package for that. And so you can see this package under development at our rOpenSci labs/package reviewer. So that was a great surprise to get this cool package. And we also want to be able to better match reviewers. So if you have volunteered as a package reviewer for us, you have filled a survey, and it has this free text field telling you what your topics and skills are. It used to be manageable, but it's no longer manageable because we have too many volunteers. So it's very hard now when we get a package to find the best reviewers for that. So I am in the process of writing a survey with more precise questions, so it will still take a few minutes to fill, but it will help us, for instance, when we think we need a reviewer with shiny skills, how do we find it more rapidly? And lastly, we would like to be able to run good practice, not locally, but automatically without installing the package locally. And we have even more ideas, so this process keeps getting better and more automated. I would like to end by telling you to get involved, so you should follow rOpenSci on Twitter. You should also check the official repository for onboarding, so you don't need to rely on my screenshots. You can read more about the onboarding process and the packages at this tag, and you can volunteer to become a reviewer, but if you do that, I will contact you again soon with a new survey. Now, at this point, I would like to thank you, all of you, for coming, all the speakers. But I also needed to thank other people, and I wanted to do that with R. So I have a few last technical details for you. I recently discovered that your GitHub avatar lives here, so github.com/username.png. So I wrote this full thank you function. What it does is loading my compliments. Then it takes a list of names. It reads their avatar. It resizes them. Then it chooses my small vectorized annotation function and joins the image together. So now I can thank people. So thanks a lot to the satRday organizers. So thanks to Andrew, Emma, John, Seoni, Kelly, Catherine, and Katie, and of course the satRday organization. You really did a great job making this an efficient and enjoyable experience. I also want to thank these people, Bea, Damien, and Laura, for giving me feedback on my talk. And of course, my co-editors for being such a great team, and also for feedback on my talk. So thanks to Karthik, Noam, and Scott. Scott is not a fuzzy cat in real life, he's an actual human. And my very last slide will thank all the volunteers that make this onboarding process possible. So these are all the people that were involved in onboarding threads of accepted packages. So thanks to all of them, and thanks to you. That's all.
Yeah, thanks, Mel, for the interesting and entertaining talk. Are there questions?
What do you mean by language standards?
For instance, sometimes in some of the packages you would use, it's a read underscore.
Oh yeah, we have in our packaging guide, we have style.
In some others it will be read CSV.
Oh, yeah. So yeah.
So I didn't see that in the review criteria.
So in the packaging guide, you will actually find, yeah, I didn't mention that, but we have some style preferences. So sometimes packages, so for instance, for XML, we recommend XML2 and not the XML package. And we also have naming conventions. So for instance, we prefer snake case to camel case. So yeah, we do have some style convention. So you will find them in the packaging guide.
Because as a person that didn't program for about 20 years, I battled a lot with the notations. You know, and the difference between the like when do I use the underscore and when do I use it.
Yeah, so I think some of these things are covered there, and so, but there are other resources that you could use for that as well. Like you could read the tidyverse style guide, for instance. Yeah, we can talk later too.
More questions? Yes.
Hi, thanks very much for the talk. I was just wondering what the if you carry on the process as packages get developed, do they keep getting reviewed or?
Well, you mean if they make changes?
Yes, I mean packages.
No. But they could ask for. So we trust authors to then still use best practice, and since they are then in our Slack, for instance, they also can use a discussion forum, so they could ask for feedback there, like more informal feedback about their ideas.
So you couldn't, in theory, ever take a package off your
No.
lesson?
Well, if a package had great problems, then we could take over maintenance if the author disappears, for instance, we would do that. Yeah.
Anybody else?
Look, are you ever thinking of integrating rOpenSci into R itself? Because currently, obviously, our go-to is CRAN.
Oh.
But I really like the fact how you guys have sort of a hierarchy, some equal visualization, you know.
Yeah, so we're currently in the process of improving this way to navigate our different categories, but for CRAN packaging themselves, you can use a bit CRAN as use for that. If you need to find package for a category with our human-created list of packages. So
Yeah, the reason what I'm thinking is most of our packages are now obviously install.packages. You know, and if you really want to install one of these packages, you have to have dev, you have to go, you know, to GitHub.
Oh no, so many of those packages are on CRAN too, and we have a Druid repo, so you don't need to install them from GitHub. No.
More questions? I still have a few minutes. I had a question that kind of relates to Hanya's question with how our OpenSci integrates with CRAN. So you say they're hosted on CRAN as well?
Yeah,
And
so
also
our
on
author can
OpenSci.
choose to also submit their package to CRAN. And sometimes they do that before onboarding. We prefer when they do that after that, because then you can suggest bigger changes, because breaking changes are less important if your package is not on CRAN yet. But yeah, because CRAN is an easier way for a user to install packages afterwards.
And that's then always synchronized? Or?
That's not secret, so they have to do that on their own.
That's it?
So they have to submit their packages on their own. We don't submit the packages to CRAN for authors.
Okay. Thank you.
With regards to unit testing for your packages, are there any sort of frameworks or resources we should look at? Something done tomorrow earlier?
I mean, apart from using TestStat, and we might have some guidance about that in packaging guide. I can't remember, but nothing I can think right now off the top of my head.
More questions? Okay, if not, Mel is also still here during the day, I think. So
Yeah, and if you want stickers, you should come and talk to me.
you can also talk to her in the coffee breaks and during lunch, I believe.
Yeah.
And I want to thank again Ben for this talk. And also all the other speakers we had this morning. And then I think it's time for our first coffee break, which actually don't know, upstairs, downstairs?
Downstairs.
Downstairs, okay.